Good morning, everyone. How are we getting on with our coding? Anyone got any questions? Just post them in the chat as we get started and we wait for others to join. Okay, so today we shall be covering something new. We shall be covering part 4, actually. So we'll be covering part 4, and it's all about constructs. But before we go into that, I want to start by going through the problem sets. And what I'm going to do is I can share with you the repository. I'm going to share this in the chat, or I'll share this in class. But I want us to start off by walking through these problems and trying to solve them, because I know they are not obvious to everyone. So we'll try and go through each of these. So let me first of all start by checking, did anyone have any problems going through these challenges? Anyone have any problems going through these challenges? If you've had any problems going through these challenges, can you please show a thumbs up? It will be much better to start off from that point. Anyone had any problems? No problems? So everyone was okay with, let me share my screen so that you can see. Oh, let me first of all make sure everyone can share their screen. Good. Yes, this is what I want to share. And I can come down here. Okay. So you can see my code, you can see my pages. I will make this bigger. How do I zoom in? I want to zoom in so that you can see. Increase font size, Control Shift Point. There we go. So that should now be more visible for you. So did anyone have any problem with question 1? Python provides a function to calculate square roots in a math library. So this is an introduction of the math library. Python has many libraries, so this is one which is full of functions. In fact, let me see if I can show you that. Oh no, I don't want you to see this. I want you to see, we had Python open, so docs.python.org, and I'm going to the library. Yes, it's full of all manner of libraries. The string library, regular expression library, binary data services, data types, and so on. So it's so rich, full of all these different kinds of libraries. So import math, and you can then use the math dot square root. So the square root function is inside the math library, and we reference it by referring to the math namespace and the square root function, and then you put in a number. So I hope that was straightforward. Using the function from one, complete the solution to get the two roots of the quadratic equation. And by the time you do this, you'll realize that your solution will probably not work for certain equations. So if you have an equation like 1 as x plus x squared plus x plus 1, it will give you a d squared, which is less than 0. And you won't be able to solve that. And that's now where the next part comes in. So you use now the C math library. So the C math library has got complex math functions, and it exactly mirrors the math library. So if you just replace math with C math, everything will just work correctly. I hope everyone tried that out. Did anyone not try that out? Just give me a thumbs up if you didn't try that out. So everyone tried it out. Also, Muhammad, you didn't manage to try it out. Okay, so please, the best way to learn programming is you strike while it's hot. When you've got the knowledge fresh in your mind, that's the best time to put it into practice. And so Python has a built-in type called complex to represent complex math. And you can use it to solve, you know this from your engineering, you've probably shown that you use J just like Python does. You can create complex numbers by passing two numbers to the complex function. For example, create a complex number 5 plus 7j, simply use complex 5, 7. I learned something recently that you can actually just say complex and you can have a string 5 plus 7j, and it'll make for you a complex number without a problem. It makes it, so that's cool, very nice. Modify your program to now accept complex numbers for A, B, and C. So now your quadratic equation also has complex numbers. So any questions on that bit before I rush on? Any questions? Any questions? Going once, going twice. Yes. Please ask your question. You can turn on the mic. Are you able to unmute yourself? If you prefer not to have your voice, you can then type it in the chat.
Excuse me, sir.
Yes.
I tried out the problem, whatever you just
Number
shared.
4?
Yes, number 1, I tried it
Number
out.
1. Yes, yes.
But I wasn't able to solve the problem.
Okay.
Yeah.
Do you mind sharing your screen? We can just walk through. This will be very illustrative for the rest of the class, so please don't be shy.
Okay, don't mind.
Okay, thank you. Very kind of you. Let's all give a thumbs up to Damaris for being willing to share her screen. It's always good when someone can, help the rest of you by sharing. Okay, good. Thank you. Okay, so, okay. Aha. So we have import math to square root. Okay. Aha. I see what you're doing. Okay, then. Thank you for sharing that. I really, really appreciate that. Now, let's point out a number of things here. What I'll do instead is I'm going to solve the problem on my end, and I'm going to show you step by step. So I have part of the code, so you can stop sharing, and I'm going to show you where the math to square root comes in. Okay, thank you very much for that. Okay, so let's look at my screen here, and you can see the example that I have. I had half solved the problem. If I run this code, it asks me for x1, and I can give it 1. And then 2, I give 2. Okay, no, so we want A, and we want B. Oh, this was for D squared. Okay then. So I'll just ignore this. Let me just start it from scratch. Don't worry. And I'll call the program quadratic. So I open a new Python file and I'll call it quadratic.py. Now, let me show you one of the cool things about PyCharm is you can define within the settings some templates. that you use. So I have a template called main, which quickly populates this code. Now, for you to do that, you go to PyCharm, settings, and there are, in the editor, there are templates somewhere down here. Now, this will all be in the recording, so don't worry about memorizing this. Templates, I have some Python templates, and I have one called main. So whenever I type main, it will put for me this code here, import sys def main, and it's going to put for me end. That's where the cursor will be. So that's what I just did right now. I used this live template to very quickly put in place the kind of code that I like. So as I said in the little book, try to make sure that you always have this structure: import sys def main, okay, and then return 0 if name equals main, sys.main, sys.exit main. Have all your programs like this, because there are certain types of programs which will not work without this. And those are the ones to do with multi-threading, multi-processing. And you want to just have the right setup from the beginning. Now, so we're trying to make A, and we're trying to make B, and we're trying to make C, and then we calculate the discriminant. And the discriminant here is going to be, I'll call it D, is equals to, we said it is B squared minus 4 times A times C, okay? Now, if we try and, we'll print out what our D is. So we'll just say discriminant is equals to, and we'll put in D, okay? So now if I run this, the shortcut for this is, on my Mac, it's Control-Shift-R. So if I run that with Control-Shift-R, it's always good to learn the shortcuts. I think it'll make you more productive. So here I'll put 1, 2, and 1. And we know that the roots of a quadratic equation with values 1, 2, 1 is going to be minus 1. Okay, so here the discriminant is 0 because these are exactly equal to one another. However, if we run it again, and you can run it again by doing Command R or Control R, 1, and I put 1, and I put 1, now my discriminant is negative, and that's a problem. But we want to center on the first one here, the first problem here. So we said the first thing you need to do is add import math just after import sys. So I'm going to write import math. Now, let's go to the documentation, because I really want you to see this. If we go to the math library here, this is on docs.python.org. If you just type /library, it'll automatically take you to Python 3. So the math library is full of functions. And one of the functions is, and I want to teach you how to read the documentation, that's very important, is the square root somewhere. Here is square root function, okay? And we call it like saying this, okay? Return the square root of x. So only you have to give it a number. You have to give it a number. If you give it anything that is not a number, it will have a problem. So now we have math imported. If you notice, math is grayed out. It's grayed out because we haven't yet used it. So PyCharm is smart enough to let you know when you are not using certain libraries so that you can delete them. And in fact, it has some nice special shortcuts that you can use to clean up your code very quickly just with a shortcut. Now, what we wanted to do is compute the square root of the determinant. So let's just calculate the roots. Now we know the roots are x1. X1 will be equals to minus, we'll put this in brackets, divide by 2 times a. So inside here, we're going to have minus b, and we have two roots, one which is plus and one which is minus, and we need the square root. So it will be math.square root of what you get from calculating d. So that is x1, and x2 will be a copy of that. I've used a shortcut which duplicates a key. It's Command D on my computer. It's very useful to learn shortcuts. You'll move very fast. So the only difference between these two here is that one is positive here and one is negative. That's all. So let's actually write these now. So x1 is equals to minus b, that one, and x2 is equals to that. And then we can now print the roots are, And I'm going to make this just a normal string, not an F string. And then we'll print out x1 and we print out x2. Sorry, I'm using code completion here because it's enabled. I should turn it off so that I type, but because we are short on time, I don't want to do that. So now we are using square root only on the value of d, not on the whole equation. I'm going to pause here for any questions. Any questions? Damaris, is that clear?
Yes, it is. Thank you.
So let's run it now. Command R. If I run it now, let's just run that. I don't know why it's doing that. Command R. Okay, it's something else is cached. So 1, 2, 1. It says our roots are -1 and -1. That's good. But if we run it again now, and we give it 1, 2, well, sorry, let's skip this one. I want 1, let's run 1, 1, 1. Now you remember the discriminant was -3. We are getting the square root of a negative number. And now we have a domain error. That the square root, we're trying to get the square root of a negative number. Now it's not obvious here that it is negative, but we have printed out d, and here it is -3. And this is where CMath now makes a difference. So if we just change this to CMath, and we change this to CMath, now you see, because we've changed math to CMath, PyCharm tells us there's a problem. Math has not been imported. It's an unresolved reference. So we change this here to CMath. And then we run this again. And now we go with 1, 1, 1. And now we get complex roots because it can calculate values of this. Notice that the value here is complex. That's what you get for your root. But it's able to add those. Those are the operations that can be combined between a number, a float, and a complex. You can add them together and you'll get a complex. So it usually just means a change of domain. It will go from a real to, you can add floats with complex. That is perfectly fine. And then I think the other thing that I was going to say we need to do is just change this here. Now, again, I'm going to show you a trick about PyCharm. In PyCharm, you can select multiple items for edit. So what I do is I double click, I click the Alt key, and I double click everything else that I want to change. And I can write that complex. So I can type in multiple places at once. I can have multiple cursors. That's very powerful. So let's run this again now, and I can give it, let's say, 5 plus 7j, 3 plus 2j, and 4 minus 10j. And it can still calculate. Our discriminant is not only is it negative, it is also complex, but we can correctly calculate the solution for that. Any questions? So we've gone through all these right now. Now, I have added that to the repository. I'm going to commit it. The shortcut for this is Command K. I think it's Control K on Windows. And I'll say solutions complex, solutions to complex quadratic. And I will commit and push. I'm pushing it to GitHub. That is the commit I've just added. And when I push, look at the bottom here, it's pushing. And so what I can now do is I can go to github.com. I go to my repository. Let me sign in. I use my passkey. I have a passkey for that. I used to use my fingerprint. And now it takes me to the latest pushes I've made. Let's just go to my dashboard. And I think I had, let's just see, Python for engineers. There we go. And you'll see that there's a commit just now, and that commit was a quadratic function, and that's now available for anyone to play with. So this is my repository. I'll just give you the name of the repository and you can look at the code from there. So I'll put that in the chat. Maybe I should also post it to class as some material. I'll do that later on. But you have it in the chat. Okay, now let's go to the next set of exercises where we were looking at the lists. So we had this example here, which was how to do matrix addition. Did anyone try this matrix addition? Give me a thumbs up if you tried matrix addition. Any thumbs up for matrix addition? Even one. Come on, redeem the class. Oh, we need to practice, folks. We need to practice. So I want you to try this out. I've given you all the clues there. And then for the next one, it was an example of how to count characters in a word using a dictionary. So this example shows you that we'll use a dictionary called character count. And for each letter in the word, we will count how many there were, and then we print out. So just type that out and run it. And then what I'd like you to then do is do the exercises. As you go through, interact with the various kinds of operations. I have broken them out so that they're available for you, kinagaubaga, and you can see them. Same thing with dictionaries. You need to play with dictionaries, look at the different operations. I've broken them down into different groups, those for reading, those for updating, those for deleting. Then operations on or between dictionaries, again, I've separated them out for you very neatly. And now you've complete the program. So that's the exercise, the challenge, add two matrices together. And if you're feeling really brave, I want you to try and multiply two matrices together. And then for the dictionary exercise, counting words in a long string. So suppose you have a long string and you want to count the words in a long string. So in the first exercise, we were counting the characters. Now we want to count the words. This is a good exercise for you to start playing around with text, because if you're going to work with LLMs and you're going to work with AI, being able to fool around with text is so important, so important. And I've given you the important operation there. It's a split operation. And using your generated list of words, count the occurrence of each word to form a tally, print out the 10 most frequent words using the sorted function. So that's an operation that applies on all kinds of sequences, whether they are lists or tuples or strings. Any kind of sequence can then be put into a sorted the operation. So today we are going to look at constructs. And with constructs, I'll type this out so that you can at least have it somewhere. And I'll call it divisors. So let's just make a new file, divisors. And again, I'm going to add it to the repository and I'm going to put my template, which I always use, import sys def main, return 0. If name is equals to main, sys.exit main. Memorize that. It's going to save you a lot of trouble. So we want to say joint divisors is equals to a list. So we have just created a list. So we know that the operations that apply to this are things like append. We can do joins. You can do all sorts of things. Those are the operations that are available for us on that. And then we have another list called other, which is another list. It's exactly the same type. And what we are going to do now is we are going to do a looping construct. Now, we will do a number of things here. One is we'll use a special function called range. Range. Now, what range does, and I'm going to illustrate this in the console so that you can see this kinagaubaga. Whenever you use range, if you say range 5, it'll give you a range, not a list. It'll give you something called an iterator. It'll have the values ready, but it won't give them together as a list. So if you say range, it'll create a range object. Now with that range object, it'll have 5 values in it. It's called a range 0 to 5, but it doesn't give you the number 5. I want you to make a note of that. It will only give you 0, 1, 2, 3, 4. How do we know this? Well, we can coerce. Remember in the second part, we talked about coercing atoms from a string to an int, from a string to a float, from a string to a complex. We talked about coercion or casting. You're forcing something to be something else. So here we can coerce a range into a list so that we can actually see this explicitly. So if we say we want to coerce our range into a list, now it will give us our list. Notice there is no 5 in it, but we defined it with 5. As with most other programming languages, we count from 0. So it's cut 0, 1, 2, 3, 4. So that's how we count. And that's why in this list, we only see 0 up to 4. And if you get the length of, I don't know if you can get the range of the length of a range. Let's see. Maybe it's going to fail. It does actually work. So the length of a range will give you the number that you put in to create the range. Now, the thing with a range is you can actually do a lot more. So let's go to the documentation and see what you can do with a range. So if we are in our documentation, we can go, let's go up. Oh, wow, they've really organized this badly. I don't like the way they've done this because I don't want to, I want to go to the library homepage. So I just remove math. And we can, there are a number, there's a section here which is built-in functions. If we click on that, it will show us the list of the key functions that show up that you can use all the time. They're called built-in because they're available without you having to import them. So they will always be there. Anytime you want to call these, you don't need to do an import. They are available directly. Now, we are specifically interested in this particular one called range. So they are arranged in alphabetical order, and we can click on that and it tells us what that is. So range is actually an object. So there's a class that this range refers to. Now, what I did when I said range 5 was I just gave it a stop. So there are two signatures for range. You can either just give it a stop, or you can give it the start and the stop and the step. So if you either give it one argument or you give it 3. Nothing. Well, you could give it 2 and it'll assume a step of 1. Yeah, so you could give it 1, you could give it 2, or you could give it 3. So let's look at that. So we are going to say, now we're going to say range, and I'm going to say -4, and I give it 5. So here's a question. Type the answer in the chat. What will be the numbers? I'm going to coerce this into a list so that you can see it explicitly. Can someone run this and see what you get? So remember, just open your Python console, clicking Python console, and then run this list range -4, 5. What do you get? I want to see the answers in the chat. The repository shortcut. Repository shortcut. Sorry, I don't know what you mean. Could you please clarify what you mean? The repository shortcut. Oh, to commit, it's Command K on my Mac. So it'll probably be Control K on Windows. And feel free to type in your question so that everyone can see the question, because I think it is good. When we ask a question, we benefit everybody. We benefit everybody. So I'm waiting to see who's the first one to give us the result of list range -4, 5. Okay, well done. Well done. Now remember, by default, the step is 1. So it will give you -4 and it will keep increasing by 1, 1, 1, 1. But it won't give you the 5. So it will give you up to 4. Okay, great. So let's try one more thing. So let's just see that. Yeah. Let's try, if I said list range 10, and I said -7, and I said -2. What will it give you there? Yeah, and let's give a thumbs up to all those people who've given us a response. Thumbs up, thumbs up. Thank you for sharing. So what do we get? List range 10 minus 7 minus 2. And does that make sense? So we get 10, 8, 6, 4, and minus 6. Thank you very much. Thumbs up to Omolo. Well done. So what is happening here, because we gave it minus 2, the step will be decreasing. The step will be decreasing. Now, if you gave it a plus 2, I think it will give you an error there, or it will give you nothing, because that's nonsense. You can't go from 10 to minus 7 with positive steps. So just a little piece of information for you there. So let's go back to our example. So we now are going through a loop. Now, for number in range 100. So let's just say, what are the numbers in range 100? Can someone type the answer there? You don't have to type all the answers. What's the first number and what's the last number in range 100? What's the first number and what's the last number in range 100? Excellent, Florence. Well done. Let's give a thumbs up to Florence. Excellent. Thank you very much. And that's correct. And then we shall do something there. We'd say if number, and then we have an operation through an operator, which is percent. I want to know, does anyone know what that percent does? Does anyone recall? So type in the chat, number, percent 11 equals 0, then joint divisors, append number, else others dot append number. And then we are going to print joint divisors, and we are going to print other. Okay, so it gets the quotient. Good direction, but I want something slightly more specific. Thank you for that attempt, Owen. Thank you very much. Timon, well done. It does give us the remainder. Excellent. So here's a test for you. If I had 7% 2, what is the answer there? 1. Excellent. Thank you very much. So if you divide 7 by 2, 7 is not even, 1 remains. So that's how we get that. So here what we are doing is we are looking for each number in 0 to 99, from 0 to 99, we check if a number has a remainder of 0, that means the number is divisible. So we are checking for divisibility by both 2 and 11. Now, there are not many numbers which are divisible by both 2 and 11. They're actually the even multiples of 11. So we should probably be 22, 44. That's what we would expect, at least in my mind. So if they're divisible, they go in here. And if they are not, so everything else goes here. Everything else. And then in the end, we print. Okay, so here we're taking advantage of the operations. But we have introduced 2 new things. One is we've introduced a looping construct, and we have introduced a branching construct. And we shall soon look at the structure, the general structure of these constructs. So let's run this now and see what it gives us. Well, the joint divisors, aha! Now, notice that the numbers here are actually very many. What have I done that I expected only maybe 3, 22, 44, 66, 88? Why do I have all of these? Why do I have all of these? Can anyone try and give me an answer? For the others, it looks like these are all the odd numbers because they are not divisible by 2. But my joint divisors, that doesn't sound right. Joint divisors should be a much smaller, a much smaller list. So anyone have any idea? Any ideas why our joint divisors? These are not joint divisors. Let me run it again so that you can see. The joint divisors are so many. Let me print a line in between so that you can see that. I don't expect this. What is the problem here? What is the bug? Can someone point out the bug? Excellent. Let's give a very big thumbs up to Jobic. Yes, now can you elaborate, Jobic? Could you maybe unmute yourself so that we can get a clearer explanation? What is wrong with OR? What is wrong with OR? Anyone want to give him a hand? So that is OR is a Boolean operation. It's a Boolean operation between the Boolean value you get here and the Boolean value you get here. But what does OR do? So let's actually look at that in the Python console. So if we have, suppose both of those are true or true, then we'll get true, right? But suppose we get true or false. What do we get? What do we get when you get true or false? You can type it in the console. What do we get? We get true. And it's the same because OR is a commutative operation. So you'll get the same value as false or true. We get the same. Actually, you can actually do this. You can say true or false is equals to false or true, just to prove to yourself that it's commutative. In other words, it doesn't matter the order. They are the same. So then what should we do? How do we fix this? How do we fix this? What is the solution? We want joint divisors. In other words, divisors that are both divisible by 2 and divisible by 11. So what do we need to change? Replace or with and. Okay, then use and in place of or. Okay, then Omolo, thank you for your answer. You're right that we replace it with and. You're thinking in C++, which is good, very good. You understand what's going on. Thank you, Timon. So let's give them a bit of love. Just give them a thumbs up. And that's correct. So we want this to be and. We are looking for the conjunction of these two events. So if we run that again now, we actually now get what we expected. 0, 22, 44, 66, and everything else goes here. Any questions on that? Any questions on that? Any questions? Going once, going twice, going, gone. Okay, now let's move to the next example. Okay, so now we've looked at these two things, the for, which has a certain structure, and the if, which has a certain structure. Now, let's break this down. To break this down, we have to start with the idea of code blocks. Now, Python is quite unique the way it is designed because you have to indent your code. That's different from C, C++, other languages, because in other languages, you can actually write a whole program on one line. As long as you put semicolon, 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 it doesn't really matter. But in Python, it's very strict. You can still write things using semicolons, but for you to be proficient and communicate clearly with other people, then you need to have code blocks. So what are code blocks? Code blocks are the sections which are separated by a tab. So always you'll have the main code block. The main code block is where you have no tab. So you do all your imports at the 0th code block. And when you write a function, you will then indent everything in that function for it to be associated with that function. Okay, look at this. Here we have an if, and inside here we have to put a tab. So this is one thing that can trip you up when you're getting started with Python because other languages don't emphasize this. Now, the way it's structured is, yes, you do have the main code block, but every code block, whenever you deal with constructs, will have this structure. There'll be a header and what's called the suite. The suite is the body of that code, okay? Now, for each of the different constructs, they have their own header. Now, for the if construct, we have what's called an assignment expression. That's the general term used for that, an assignment expression. And we'll see later on, you may see why it's called an assignment expression. But for now, all we care about is this. The assignment expression must be Boolean, or it must evaluate to a Boolean. Doesn't mean it has to be a Boolean, but it can be evaluated to a Boolean, which means Python can, by some means, turn whatever it is into a Boolean. So that is your if. Now, the if usually doesn't work alone. It can work together with something called an elif. And the elif is an alternative. So it will say, can I check this first? Can I check this second? Can I check this third? So, and then it will then fall back on an else. So whenever you have multiple conditions you want to check, the number one thing is that those conditions have to be exclusive of one another. If you're checking if a person is let's say, like in this case, we were looking at whether a number is divisible by both or not. Those are exclusive. A number cannot be both divisible by 2 and 11 and not divisible by 2 and 11. So whenever you're constructing this, you'll have to have that the other assignment expressions are exclusive. Now, let's now look at assignment expressions. So what I'm going to do is I'm going to commit this and I'm going to push. So this is example of using for and if, and I'm going to commit and push. I have shortcuts for that, so that's why I do things quickly. But anyway, so let's look at now constructs. We'll start with if constructs, if constructs.py. Okay, there we are. And I'll add this to the repository and I will add my template as before. Now we want to look at assignment expressions. There are 4 types of assignment expressions. There are assignment expressions like the example we saw here with the divisors. In this assignment expression, we were doing comparisons. So we used comparison operators to carry out the comparison operation. And the comparison operations are what you see here. You can check whether something is less than, check whether something is less than or equal, check whether it's greater than or equal, whether it is equal, whether it is not equal, and whether it has the identity or is not identical to. Now, the last 2 are sort of like special cases. We can ignore them for now. But comparison operations fall into these groups. Now, what I'd like you to do right now as an exercise, as I grab a cup of water to moisten my throat, is open your Python console, and I want you to play around with those examples there. The ones that are listed there. Print 1 plus 1 is, and then check whether it's equal to 2. Then you print X, you compare it with Y, and so on and so forth. Okay? And I'll be back. Okay, so how are we getting on? How are we getting on? Anyone managed to finish all that? If you have, just can I get a thumbs up? Can I get a thumbs up? You know, I'm blind here. I can't see anything. So if you don't show me thumbs up, then I have no clue whether you are. Anyone finished? There are more actually. Anyone finished? Why don't I just type it here? I say finished. Can I get a thumbs up on that finished, please? Okay. I will assume that you can continue later on. So let's just move on. I'm not getting any responses on whether anyone has finished. So I'll leave that for you as an exercise. Now, we said there are 4 types of assignment expressions. What are assignment expressions for? They are for the if, the header of an if. An if is just if an assignment expression. So all you see here with these examples down here, these are assignment expressions. You can literally put them, the ones which are with the double equal or with the equal or less than or equal, you can put these into the if statement. Now, another way you could check is to use what are called membership expressions. And that's what we have used in this main example here. What I'm highlighting here on the screen, no, not for the for loop here. Since we are talking about for an if, then we are saying if membership. So let me give you an example of that. If I say if 7 is in range of 10, we expect true or false? True or false? Can I get an answer in the chat? True. Thank you, Timon. I should actually tell it something, so I can't just leave it like that. So I'll say print true. So let's see, does this work? Yes, it does. It means that 7 in range evaluated to true. So this is a second kind of, let me actually make some notes on the screen so that you can just be seeing this as we go along. Let's make some notes on the screen so that you can see them. So I will use my little pen here. Let's give me a second. So we said that one is we have the assignment expressions, which are the comparisons. And then the second we have checked is the membership. So the comparisons, we said it's like equal. We are comparing less than or equal. There is not equal, and so on. Okay. Now membership has the keyword there is in. In, and we'll put that in quotes. The third group of assignment expressions are what are called, so these are implicit Boolean expressions. Now this is a bit of a mouthful. Let's just figure out what these are. So I just call this the implicit Booleans. Booleans. And the implicit Booleans apply to things which can be coerced to be Booleans. So let's look at an example of that. So I have examples here. So if you have integers, 0 evaluates to false. So let's say, for example, I had x was equals to 0, and then I would say if x, and I say print true. Now, x is not a Boolean. But if it is equal to 0, it evaluates to false. Actually, we'll never see this line. That will never appear. So if we said it the other way around, if we said if X print true, and then we said we added here, let's just put that, else print false. So it will be treated like if there's no error. You don't get an error here. I don't know why this is not. Because I have a new line here. There we go. So the false will be evaluated, which means it will read this and it will say, is this true? No, it's not. So it will then run the false part because this 0 is treated as false. Again, for floating point number, 0 is treated as false. But if we had 0.001, x is equal to 0.001, I don't think that this evaluates. So if, let's try the other way around. If not x, print true. I'm sorry, I have someone at the door, so I'm going to. So it doesn't evaluate because x is evaluated to true, not x evaluates to false. Therefore, it will not print true. Give me 1 second. I have someone at the door. Sorry about that. Okay, so so those are implicit booleans. Here we've got the floating point. If it is not exactly 0, it has to be exactly 0 for it to evaluate to false. Otherwise, it will evaluate to true. For strings, the empty string evaluates to false. We can actually try this. If we say, is that equal to false? And okay, because it's not Boolean. It's not Boolean. But when we use it in if not empty string, print true, okay, so what has happened here? So this is empty. Empty evaluates to false, not false is true, and therefore if true, print true. Okay? Quick question, why not say print true? Well, I could, you're right, as in, it doesn't really matter. You're right, but here I'm printing the string true. I mean, you could also print the string false, but a good point. It doesn't really matter though. Why use print true? I could print anything. I'm just using string. It could be print Paul, print Owen, okay? Give me a thumbs up if that makes sense. Lists and dictionaries. An empty dictionary. I hope you're getting the theme here. Thank you, Owen. I hope you're getting the theme here. The theme here is if anything can seem like a 0, then it will be false. So an empty string has a length of 0. An empty list has a length of 0. The number 0, the number 0.0, and none type, the none type value none also evaluates to false. Now notice here I'm saying it evaluates to. I'm not saying it is equal to. It's a coercion. So an assignment expression will quietly try and do a coercion in the background. It will check, can I, in one way or another, reduce this to a Boolean? And can it reduce it to a Boolean like one of the ones that are listed there? Okay. Okay, so that is it for implicit Booleans. Now let's look at one more type. One more example is function-based evaluations. So I'm going to write this here. So the fourth kind of assignment expression, if I can get this to work, is function-based. Now we are about to look at functions. So function-based, and this is very simple. This is a case where a function returns a Boolean, or it returns an implicit Boolean. So I'm going to do a very quick, so now maybe it would be a good time to show you what a function looks like. Actually, you already know what a function looks like because we have this def here. But let's do one simple, very simple function here. I'll have a function. whenever you define a function, you have to do three things. You have to give def, you have to give the name, I'll call it eval, and then you have to give it some arguments if necessary. In my case, I don't want to give it arguments. I just want it to return false. So here, my function is, okay, we shouldn't use eval because that is eval bool, okay? Because that is, I'm overwriting an internal function. So if I do that, actually, I'll do this on the console. I'll just write my function there. So now I have a function called, if I look at locals, I should see my function should be defined somewhere here. Where is it? Oh no. Okay. My dict. It should be right here at the end. There we go, eval bool. So locals is a way for you to see the local things, everything, all the local definitions. And you can even see it here on the right that, I don't know if it is specified here. Here it is, eval bool, which is a function. So then I can now do if eval bool, and I have to call it. And I'm returning false. So let's convert that false to true. If not, eval bool, and I'm going to do what Owen was asking. I can print true. Or I print whatever, okay? What we're just proving is that the value of the assignment expression has evaluated to true. And that's a key thing with the if conditional, if construct. For the code in the suite, so you remember we talked about that there is a header and a suite. The code in the suite, let's just go back here. The code in the suite, for the code in the suite to be accessed, the assignment expression must evaluate to true. That is the most important thing. It must evaluate to true for the if construct. Okay, so that's function-based. And I've given some examples there, but essentially it's just a function which is returning that value. So these are the four types of assignment expressions. Now I want to give you, we've already looked at compound assignment expressions like what we have here. So compound assignment expression is now where we apply the operations on those Booleans. The Boolean. Can someone write in the chat, what are the three Boolean operations? What are the three Boolean operations? What are the three Boolean operations? Can someone write them in the chat? Okay, excellent. Okay, then. Very good. That's a funny one. And or not. That's a bit confusing, but yeah, thank you very much. We'll just give a thumbs up to all these people for participating. One day I'm going to give prizes for participation, and let's see if that's going to improve your participation. Okay, but we have and here, we're using and here, and we are just getting the anding. It's like the multiplication of the Boolean values there. Now, with compound assignment expressions, I think we've seen examples of this. This is when you now carry out multiple of them. So like this example here. So in this example here, we can use parentheses to group the Boolean operations. So that's what we do there. Okay, now I wish I could give you a little exercise, but we have 55 minutes remaining and I have two more things to cover. Do we have any questions? I'm going to pause here before I move to the for construct. Any questions? Going once, going twice, going, gone. Okay, so now let's look at the for constructs. Actually, I really want you to do an exercise. Okay, this is the exercise. I want you to write a simple module. So you're going to come to your PyCharm, right click, say new, say Python file, and then you'll give it a name. So we'll just call it whatever you want to call it. Let's call it ungrammatical. Okay. Now I'll add it to the repository, and then I am using my main template. So what I want you to do is ask a user to enter his or her name and check that the user has correctly capitalized his or her name. For example, if I enter Paul, the program should report ungrammatical, right? Paul instead of Paul. Try using else to alternatively print hello Paul if the spelling is correct. So there are two parts to this. Part one is this part, which is if I enter it incorrectly, I want it to warn me. And the second part is this one, try using else if the spelling is correct. So I'll give you 5 minutes. 5 minutes. I've given you a sketch there. Maybe what I can do is just add a little more. So name is equals to input. Please enter your name. And then I want you to now write an if construct, which will check to make sure that this name is correctly spelled with a first letter being a capital. Now, the trick to solve this problem, I'll give you a hint, is you go to, remember this is going to be a string. If it is a string, then we want to look at the string operations. So we'll come to the string table here, and I'll paste this in the chat, because I want you to have the code on your screen. So I'm going to put that there. Now use the string operations, go through the string operations and look for the ones which apply to this. So I'll give you 5 minutes. I will come back at 12:12. Okay. Has anyone finished this little exercise? Has anyone started this little exercise? Can I have a thumbs up if you have started this exercise? Anyone started? Anyone at all? Okay, Alex, thank you very much. Alex, do you want to share your screen so that we can learn from you and we can walk through? Don't worry if you haven't completed it correctly. We will just use what you have as a building block. Anyone want to share their screen so that we can learn how to do this? Anyone? Come on. Anyone? I can pick on someone. Kelvin, could you please share your screen if you have done it? Okay, I will leave it as an exercise for you to practice on, and I'm going to move on. Yes, Brian, you want to share your screen or you have a question? Oh, thank you, Brian. Oh, man. Thank you very much for that. Let's give a thumbs up to Brian for sharing his screen. Thank you so much. Thank you so much. Okay, good. So, import sys, okay, very good. You have the structure, good. If name dot starts with dot upper. Okay, excellent start, excellent start. So let's try and just walk through this and we'll get you running this correctly. So the first thing I will say, and I'm going to write on your screen. So the first thing we need to do is remember in Python, we have our every block has got two parts. There is a part which has got the header. Now, I think you'll notice about headers, they always end with a colon. So there's a header and then we have the suite. So here is our suite. And the thing that separates the header from the suite is we'll always have a tab. Always have a tab. So the first thing we need here, you've done correctly, you have a tab, but now we need this to align with it. So what I'll ask you to do is just put your cursor at the beginning of the if, and then you hit the backspace to remove that space, and then just press the tab character. The tab character will be on your screen. It'll have a symbol that looks like this. On the top left, it's just next to Q. Excellent. Well done, top marks. Now, so that's correct. Very good. The next thing we'll do is we'll say, okay, so you're checking if name starts with. The next thing I'll ask you to do is remove this space here because we need the dot to be just after. Excellent. So let me wrap that now so that you can, okay. Okay, so good. The next thing we'll do is Now, let's ask ourselves this question. Is the starts with the best method for this? So what we're going to do now, I want you to go back to my screen share, everyone, and let's look at I think I am still, oops. I want to show you, let's go to the documentation. We are looking for the methods and we'll see there's capitalize. You're right, there's a starts with, and we'll check whether it's an uppercase. But hey, look, there is one which is actually a trick. There's something called is title, I think. Is title. And the is title returns to if the string is title cased string, there's at least one character. For example, uppercase characters may only follow uncased characters and lowercase characters only cased ones. So is title is the actual, well, it's a useful one in this case. So let's go back to Brian's screen. Okay. So we are going to replace we'll just write is title. Now notice the is title returns a Boolean. So this is an example of a function-based assignment expression. So we're going to replace all of this starts with, let me just get my pen out again. We are going to replace our starts with all of this. We'll remove all of this and just put is title. Is title and close with a title. Very good. And then we shall open and close parentheses and then put colon. And now we can delete the dot up. Yes, okay, good. Put an open and closing parentheses there. Not braces, parentheses, not those are brackets. So let me show you. Remember, these are brackets. These are parentheses. Note the spelling, it's got an E there. And these are braces. Okay, so it's good to always be aware of this. Okay, so we have parentheses, and then after that we have a colon, and we can delete the rest. Colon, and then delete the double equal and the true. And now we say you write print ungrammatical write Paul. So now this is a little bit of a tricky one here. We want, so the first thing we do is we can just test it. So remove the else, replace the else with print something like just okay, just for now. But it has to be a string, so we have to delimit it with the quotes. So we'll do double quotes on each side. Very good. We can delete this, print false. And that is a complete program. Okay, so can you run it for us now? So you just click this arrow, run ungrammatic. So type your name, write it in small letters. Oh, one thing we need to do, sorry. Okay, just run it because it's illustrative. Don't worry, just run it. Just type your name, Brian, and enter. You should end up with an error. We didn't end up with an error. I don't know why it is allowing you to get away with that. So what we want is you see, we have an extra space here. So let's clean that space and then press tab. We need two tabs. Another tab. So let's go back to this idea. We said it's just important to emphasize this. We have the header. For any block, we'll have a header, and then we'll have the suite. And the suite is separated with tabs. There'll always be tabs there. Okay. Okay, so let's run that again. This time type Brian spelled correctly. Okay, so it's able to notice that you typed it correctly. Um, Now, I'll leave this for you as an exercise. If, um, okay. Ah, yes. So the question is actually asking that not if the name is titled, but if not. So that in here, we are going to write, we'll say print, and whatever should come out will be something like ungrammatical. So we are actually asking for the converse. And then it should say write, and then you'll put in the variable there. So there is now where you're going to do the work of making sure the text is correct. But well done, Brian. I'm really, really excited that you've tried it out. You have exposed some of the things that you're learning and that you're sharpening. That's really what I want from all of you. Please don't be shy. Anytime you share, you learn something. Everyone else learns something. And there's no shame. There's really no shame in this. So thanks, Brian. You can stop sharing your screen and then we can now move to the for construct. So everyone, can we give some thumbs up for Brian for being brave enough to share? Because we've all learned something from Brian. Thank you so much. Okay, now the next thing we're going to look at is the for construct. Now, before I go to the for construct, I just want to emphasize again. I'll keep saying this because it bears repeating multiple times. Because it's not easy to grasp these concepts at once. They take time. This is the key idea that everything in Python happens in blocks. Every block has a header and every block has a suite. And the thing that separates a header from a suite is just a set of indents. The indents help us mark out where the header is and where the suite is. And the key thing also is to remember that header always ends in a colon. Header always ends. Every time you're going to do this in Python, it will end in a colon. Okay, let's now turn our attention to the looping construct, which is called for. Now, this is for repeating. Again, the only thing that changes now is we have a header, which is just structured differently. The header has the following format. It is for, item, in, iterable, and then you have your body, which does something. So let's actually look at this with an example here. I'll use the code example that is on your screen at the bottom there. And I'm going to write a new project. So what I'll do is I'll come back to PyCharm. I'm going to leave this for you so that you can try it out. I'll say this is the stub for you to fill in, and I'll commit and push, and I'll just create another one. So I'm going to create now a looping. Okay, and I'll add it, and I'll add my structure. So here I have a number list, and it has numbers 8, 3, 2, 6, 12, 3, 14, 332, 72, and 9. And 9, okay? And I say for number in number list, and I'm going to get the square is equals to number squared, and I'm going to print the square. Now, I want you to zero in on one thing. We said the structure is as follows. It's for, for number in number list. Now, this number here refers to a variable. This is called an iterable. An iterable is a general term, iterable. It means you can iterate. In other words, you can go round and round on this variable. So this one refers to what we have defined here, and it's a list. So the conclusion is lists are iterable. Lists are iterable. Other things which are iterable are dictionaries, strings, generally container types or sequence types. The general term is a sequence type. And if you saw in the definition for strings, they are called text sequence types. And a list is a mutable sequence type. And a A tuple, which you can look at in the documentation, is an immutable, but I won't go into that right now. And now here's a key thing I really want you to pay attention to here. I'm going to change colors here so that you can see this. This number is now a variable. So whenever you use a for loop, you are creating a variable. You're creating a var. That's so important. Then you can use that variable inside. And there are different ways you can do this, but this is the heart of it. It doesn't get any simpler than this. So let's run this and see what it gives us. So if I run this now, I get this. I get 64, 9, 4, 36, 144, and so on. So now we are looping. We create a variable and we can use that variable, okay? So we run the example above using the standard format. I've done that for you, and I'm going to just save this looping. Now I've pushed it to the repository, so it's now available for you. Now you can actually, whenever you have a loop, the loop just faithfully repeats, okay, from beginning till the end. And sometimes you want to break, you want to interrupt the loop. And therefore we have a keyword for that called break. You may have come across this. Let me use a different color now because now it's just too bright. We use break for that if you want to break. So let's, I want you to type out that example using the standard format. Please type that out and run it. So I'll give you 3 minutes to type it out. 3 minutes to type it out. And I want you to see the effect of using break. So I'm going to pause here for 2 minutes so that you can very quickly do this. Okay, have we succeeded in getting that done? What did you observe? Can I have someone just type in the chat? What did you observe when you ran the code in that example? What did you observe? Anything that you observed? Anyone want to give me a comment? What did you observe? Or let me put it another way. In the previous example, the one I've run on my screen, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 numbers. How many numbers do you expect to get with the change, the if number is equals to 12 break? Four numbers. Excellent. Thank you, Owen. Let's give Owen a thumbs up for that. That's correct. And that's because when we use break, it will stop. It will exit the loop. Now, it's the opposite when we use continue. Continue means it will skip. So I want you to use this as a mnemon in your mind. Break means stop, and continue means skip. Continue means skip. So continue skips a loop whenever you want to skip. Okay. Um, there are some helpful functions to work with iterables there. I've already talked about range. I want you to play around with enumerate in the Python console, and I'd like you to also play around with sorted. I want us to move straight on to the last construct, and that is the def construct. Now, the def construct is used to define functions. Now, if you go back to what we had done before, we actually did an example here. We wrote a simple function. Now, again, it follows exactly the same principle that def, there'll be the header. The headers always end in a colon, and the suite or the code block is always indented. So I want you to remember this picture here. And within it, so with a function definition, what you're doing is you're transforming a block so that it can be referenced by the name. Okay? So you're actually naming a block of code. That's the right way to think about it. And when you do that, it can mean that the code that is calling that function can be shorter. Okay? So if you have a huge chunk of operations, you're doing something, you're turning something, multiplying something, dividing by something, and doing all that, you can take all that outside and write it inside a function. So let's actually see how that looks like with the quadratic problem. Now, with the quadratic problem, we were trying to calculate all of these. Now, what I can do is I can actually replace all this block, discriminant and all that. I can replace them with a calling, a call. So what I'll do is I'll say define a function. We'll give it a name. Now I'm going to ask you to give me a name for this function, just to make sure that you're awake. Give me a name that we can use for this function. Anyone type a name in the chat. What name should we call this function? Discriminant. Okay, that's good. Thank you, Owen. Let's try and see if we can make it better. Anyone, including Owen, you can improve upon that. Let's try and improve upon that. Quadratic. Okay, thank you, Timon. Can we try and improve upon that? I'm looking for something very specific. Okay, Owen, thank you very much. You've done what I'm looking for. I want us to pay attention to that. So Owen has given us an example, find discriminant. Now, let me ask you a tough question. What is the part of speech that the word find represents? So within the English language and all languages, we have different things, different what are called parts of speech. We have got nouns. I'm going to type them in the chat. Nouns. Actually, let me just write them on the screen. We have nouns, we have verbs, we have adjectives, we have adverbs. If you remember all this, nouns, verbs, adjectives. Let me just move my mouse. We have adverbs. So what is, okay, good, correct, Brian. Yes, so find is a verb. So that's a verb. And what is discriminant? What is that? What type of part of speech? That's a noun. And now, so this is what I want you to be aware of. Whenever you write a function, a good practice is to give the name of the function with verb underscore noun. Why? Sorry, this shouldn't be noun. Let me just, because you want to say what the function does. This is the doing part, and this is the result or the object. So find discriminant is correct. Actually, we should just say it's called, maybe we could say find solutions. That may be even better, because that specifically will take our discriminant and compute our roots. Okay, so let's actually do that now. So we come here and we say, let's just close that. We say find solutions. Okay, and for us to find the solutions, we give it the quadratic equation A, B, and C. Okay, and then now what we do is, look, I'll just cut this. I'll literally just cut this like that, and I'll just paste that block there. So we have actually converted that block into having a name. Now, we have the only now thing we need to add, because this is a function, we want to return some values. And so we shall return x1 and x2. Okay, so let me clear my screen so that you can see this clearly. So now we have changed, we have replaced that. And now what we do is, because we are returning two values, we should collect two values. So we collect x1, x2 is equal to find solutions of A, B, C. Now you notice we have completely simplified. We have replaced the block with a name. So we are essentially naming a block, and we are passing some variables to it. We say, oh, we'll give you A, B, C, and you'll give us X, Y. And that's what we have done there. Now, if we run this, it's just going to work exactly as before. I don't know why it keeps doing that. Let's just close the annotations. Find solutions, and we have X, Y. Oh yeah, we have C math. Oh, that's fine. I will close that. So now if I run that, now another thing I want you to notice, do you see this green line here? This green line is a way for PyCharm to show us the new changes in the file. If I click on this, it gives me some options. It says I can go through the changes, but I can roll back the lines. We don't want to do that, but it's just showing us this is where the code has changed. Actually, this is where there are new things. Remember, green means new, blue means changed. So here, this is how it was before. And now we have completely changed it. We've reduced it to one line. So I'm going to run this. Oh, it's still running the previous one. So I'm going to run this. And now when I run this, it's exactly the same. I can give it 5 plus 3j. I can give it 7. I can give it minus 22. And it will give me my solutions. Nothing has changed. We have simply used a construct called a function. And we have then changed that block to just be a name now. And we pass what it needs, 3 variables. We give it 3 variables. And it gives us 2 variables. We pick 2 variables. That's it. That's all we've done. Okay. Now I'm going to commit this, and I'm going to push now defined function for computing solutions, and I will push that. So that's now available for you. And there are a number of rules there. So I've specified how we define a function. I've gone into a lot more detail here, things that you need to be aware of. I think I also mentioned that I reference a part of the document which tells you about what are called naming conventions. What are good naming conventions? The rules that you follow to give something a name. There's a section in early on where we talk about naming conventions. And then we have the return, which is at the end, this part at the end. If you omit the return, it will automatically return none. It will automatically return none. So there are some instructions there about arguments. The arguments of a function are the inputs. So this is a picture to just show you arguments. Like here we have our arguments are A, B, C, and then the result is X, Y. Okay. Now I want to give you an exercise in the remaining 20 minutes. Okay. There's something about doc strings, but I really want you to try something out. So we go back to example 1. The divisors were hard-coded. Yeah, so I've already pushed this divisors, okay? Now, what I want you to do is to write a function called get joint divisors, which takes divisor 1, divisor 2, maximum. I don't know, why do we need maximum? Maximum, what is maximum? Do use the same with the maximum value, so the range of values considered can be changed. Okay, that's going to be complex. Just ignore the maximum part. So it'll just take 2. And I want you in the remaining minutes to do this exercise, and then we'll come back at the end and see. So I'll give you 15 minutes, 15 minutes for you to walk through this exercise. 15 minutes. If you need help, I can set up breakout rooms. Choose. I will let the, let's just see. Room 1. So I'll create a breakout room. If you want to join that breakout room, you can come and find me and ask me in a way that is more private. So let's see. I'll just create a breakout room. And there's one room. So if you have any needs, just go to the breakout room and I'll see you there. Or maybe I can create more than one breakout room. Let's just see. Let me close the breakout rooms. Let me just create several rooms. Okay, I've created 4 breakout rooms and I'm going to open them and I'll keep jumping between rooms. So if you need help, I will find you. Come and find me in one of the breakout rooms. Or just go and wait for me and I'll come around and give you a hand. If you want to stop here, just give me a thumbs up. In the chat. I see the class is reduced now. We are less than a third. Is anyone trying out the problems? I just want to know so that if we want to stop now, we can stop. So if you are trying out the problem, give me a thumbs up. Okay. If it's useful to give us the maximum number in the range we need. Yeah, sure. Yeah, if you can integrate it, please go ahead. Let me not stop you. Please integrate it. Or hard-coded, modify the promise needs to provide two different divisors. To evaluate, do the same with the maximum value so the range of values considered can be changed. Okay, yes, yes, yes. Yeah, you can include the maximum as a variable. You didn't get the assignment. You didn't get what we are doing now? Is that what you mean? So we are doing challenge number 2. Challenge number 2, page 86. Challenge number 2, page 86 is write a function called getJoinDivisors that takes 3 arguments: divisor 1, divisor 2, and maximum. So you're using the code that I have on the screen. Oh, it's not sharing anymore. You're using this code here. Oops. Yeah, you're using this code here on the screen, and you are now turning that block into a function. So that's it for today. Next week, we shall look at object-oriented programming. So make sure you have a good grasp of what we have done so far. Next week will be a bit of a challenge, a bit of a stretch. So really, really, over the weekend, try and solve 10 or 15 or 20 problems, and just stretch yourself. So that's it for today. If you have any questions, you can post them in the Google Classroom. And I'm noticing you guys are very, very shy. And when you don't ask questions, you don't learn. So just ask questions, no harm, and everyone benefits. Okay, then bye, everyone.